And I say, this is a test pattern. So this is a pattern, like a gene. And it's coming from the broadcast station. And I say, well, the pattern, the gene, is coming from this broadcast. But I say, but if I mess with the dials on the television set, I can alter the shape of the pattern. Here's one form, altering that pattern. I can alter it again by changing the dials on the television set. My most important question is, yes, I changed the expression of the pattern, but functionally, did I change the broadcast? Did I change the original pattern? The answer is no. It's still the same original pattern, but I can change the readout. I said, well, how does that work in our biology? I go, here's a strand of DNA. The loop part is the blueprint, a gene, to make a protein. I say, what about all that extra stuff around there that's not part of the gene? Well, euphemistically, unaware people have referred to this as junk DNA. They say, oh, that's just extra DNA. That's really nothing. A cell is so stupid, it's carried around 1 billion years extra junk. And it turns out, what is the junk DNA? And the answer is this. Built into that DNA strand are protein modules, little clusters of proteins. And guess what these protein modules are? They are the equivalent of the dials on the television set. One is on and off. One is volume. One is contrast, focus, color. And so you can change the readout of the gene by affecting these protein modules. They are, in a sense, really the dials on a television set. So the junk DNA is not junk. It is the most profoundly important DNA of all. Listen to this. The genes get mutated regularly. The junk DNA does not get mutated. It keeps itself very constant. Why? You are getting your pattern of who you are from the junk DNA and getting the parts from the gene DNA. So epigenetics can influence either the gene or the protein modules. So when it alters the protein modules, that's protein regulation, turning the dials and changing the readout. And when it affects the gene, that's the methylation process that says whether you can read it or not. So epigenetics says which genes are going to be read and how they're going to be read.